Hello and welcome to another tutorial in ANSYS Workbench. In this tutorial we are going to look at topology optimization, and we're going to perform that analysis on this disk that has 4 holes in it. It is just simply a thin disk. We'll put a torque on this outside surface and we will hold the disk from spinning by fixing these 4 holes. So let's go ahead and begin with the tutorial. So as usual, after opening ANSYS Workbench, we will click on Static Structural, drag and drop it to the Project Schematic window. Then we will double click on the geometry to open SpaceClaim. Once SpaceClaim is started, I'll close the pop-up window, right click and select New Sketch Plane to click on the XY plane, look at it in a plan view, and the default is millimeters, and so I'm ready to go ahead with my units and start creating my circle. I'm in sketch mode. I'll draw my circle. My first circle is 50 millimeters in diameter. My small circles are 5 millimeters in diameter, and I could copy and paste and cut these. In this case, I think it's just about as quick to create the 4 circles individually on the grid locations. So now I have all my circles created. I can escape out of the circle and rotate my body. I can come and pick on Pool, select the body, and I'm going to move this 3 millimeters. Now you can see over in my structure tree I have a solid and I have these surfaces. I'm not going to need those surfaces, so I can either delete them here or deactivate them. In this case, I'll simply delete them by right-clicking on surface and then left-clicking delete. Now the only thing that will be brought into ANSYS Mechanical is this one solid, and I'm ready to bring that in. So I'll minimize the window and double-click on Model and start ANSYS Mechanical. After opening Mechanical, I can click on my geometry and see that I have my one solid. I can click to look at it straight on. I don't need to do anything with coordinate systems, and I'm ready to begin to mesh, so I will right click and click Generate Mesh and just take a quick look at what the default mesh looks like, and that's not nearly good enough for an optimization problem. So I will come and right click on Mesh, and I will come down and insert refinement, and for the geometry I'm going to pick these surfaces where the holes are for a mesh refinement, and click OK, apply, and I'll probably go with a refinement of a 2. Now I can update that mesh. That mesh is starting to look better, but I'm still going to come down and, while on mesh, open up the sizing drop down and change the relevance center from coarse to fine, and you can see that again the mesh turns yellow, meaning that it needs to be updated, so I'll click on Update. This mesh is also fairly coarse out in the body of the disk. Around my holes I think the mesh has a great refinement. So I'll come down here, and under Mesh I will click on the size function. Instead of using adaptive, I'll use proximity curvature, and then click Update to update the mesh again. Now after looking at the mesh, it looks great. Certainly good enough for this tutorial. You can see we got a really high mesh density around the holes, and we've got a pretty good mesh density in the body of the disk. So we'll go ahead and perform a static analysis. So I will right click on Static Structural, Insert, and I'm going to insert cylindrical supports, and I'll insert those on the 4 holes. Click Apply, and I'm actually going to free the tangential boundary condition on those holes. Now I need to apply a moment, so right click, insert moment. I'm going to apply the moment on this surface, so click apply. I'm going to do it in terms of components, and I want to rotate this thing about the Z axis, so my Z component, and I'll just put a default of 100 newtons in, and I now have my force. So I have my torque, my load, I have my boundary conditions set. I'm ready to define my solution, so I'll click on solution, I'll look at equivalent stress, and I'll look at total deformation. Right click on solution and solve. So we've attained the solution, we have our green check marks, we can look at the equivalent stress. This gives us a great idea that this material in here and this blue material out here can probably be cut out of the disk to reduce the mass. And if we look at the total deformation, this makes sense as well. There's essentially no deformation here in the middle, but then as we go out around, the deformation is maximum at the outside surface. So now we'll go ahead and begin to do the optimization. So to do the optimization, we'll minimize the ANSYS mechanical window. We'll come over to the analysis systems and click on topology optimization, bring it over and drop it on model. Then we have our topology optimization icon pop up. We need to click the solution and drag that over to setup as well. So now we have our static structural, and we're ready to start looking at our topology optimization. You can right click on results and click update to update the results over here in the topology optimization. After the update has taken place, you can see we have our green checks over here in engineering data, geometry, and model. So I'm going to come down here and open up my design ANSYS mechanical window, and you can see now that topology optimization has been added to the structure tree or the outline tree. Now I just work through these steps similar to what we do when we're doing a static structural. So if I click on topology optimization, I can right click and insert a bunch of different things, components. We can have an objective and then all these different constraints. We'll go ahead and leave that for now. In terms of analysis settings, my maximum number of iterations is 500 as default, and I will just leave that. Everything else here I will leave as default. On optimization region, this is where you pick the area that you want to optimize, and in this particular case I'm going to optimize all bodies, so the default there is fine as well. Then exclusion region, these are the regions or the region where you want to not have any optimization take place, and I'm going to use the default again here that is boundary conditions. If you click the drop down, you also have a geometry selection and a name selection. I'll leave it on the default boundary conditions, and on all boundary conditions I want the optimization to have an exclusion region there. Now I come to objective, and my objective is a compliance response type, and the rest of these defaults I can leave as they are. Now I'll come to response constraint, and when I click on that, this tells me that my response constraint is a mass, and it's looking for a 50% reduction. I'm going to go ahead and click on that and increase that to a 60% reduction. So I have green check marks on everything here, but I'm going to come up to manufacturing constraints and to enter in a member size, and I'm going to have a minimum member size of 5 millimeters. So I'll go ahead and click the drop down and click manual, and then enter 0.005 for 5 millimeters. I'm also going to come up and enter a manufacturing constraint as this being an extrusion, and it's an extrusion about the global coordinate system but not the x-axis. Over here it's about the z-axis, so I'll click the drop down and change that to the z-axis. So the model's now ready to be solved. We can right click on solution, and actually we'll need to come up to topology optimization, and you can see that I've solved this already. So I click solve and I now have green checks and everything. So I'll go ahead and leave this solution as it is and not redo it. It takes several minutes. But again, all you needed to do was right click on solution and click solve. To look at the results, we come over to the outline and click on topology density. And you can see the results here. You can see that all of this material here can be removed. Essentially the entire center can be removed. And then in this area here, they're showing some material that doesn't go all the way through, but that can be removed. And you see that same area, or relatively similar area, on the back side of the disk. Now that you can see where the material has been taken away, you can animate that, and you can see how that material is taken away as the solution goes through iterations. And you can certainly slow this animation down if you want to see it a little bit more slowly. Now the next thing we need to do after we've looked at these results, we need to validate the results and make sure that this new design can actually handle the stresses that we're looking for. So to do that, we minimize ANSYS Mechanical and we come over to results and we right click on results and we transfer to design validation system and left click. So essentially what we're going to do is transfer these new results, this new geometry, to a validation system. And it's essentially a static structural. You can see that we have a lightning bolt here on our results, and over here we're ready to look at our geometry. So we need to right click on results again and left click on update. Now what this will do is it'll take a minute, but these results are being transferred to the new geometry in our static structural. I'll go ahead and pause this while it completes. So once this has been updated, the results, we need to also come over and update the geometry. So I'll right click on geometry and click update. This one usually doesn't take as long, and this will update the geometry in the static structural. Now that the geometry has been updated in the new static structural with our optimized geometry, I'll double click on geometry to open up SpaceClaim. Once SpaceClaim's open, I close the pop-up window and I can look at my geometry. You can see that what ANSYS does here is it gives you a light pink geometry showing the original geometry, and then your optimized geometry is shown in a darker blue color. If you want to look at just one or the other, you can simply come here and uncheck. There's my original geometry. Now I can unclick this one and unclick the top one, and I'll get rid of the view for the original geometry, and this is the optimized geometry. So now this geometry here isn't very mesh friendly. It would be difficult to get a very good mesh to fit this. It also wouldn't be very easy to manufacture. So what I typically do now is delete all of the lines and redo the geometry with ANSYS Workbench. So I go into the sketch plane and I want to look at this sketch plane, so I'll click there, now you can see all these lines have been made. And in many cases you'll be able to just smooth those lines and have a pretty good result. In this case that doesn't give us a very good result. And so I'm actually going to come in and delete all of these lines and use basic geometry. So I'll come to Detail and I will box select, and I'll select all those lines, right click and delete. Didn't work, so I'll come and select them. Probably need to be in Design, Select, right click, cut. Now I can go ahead and start to build my other geometry, and to do that I'm just going to come to this Design Sketch mode, and for example I'm going to put a circle in here. I'll make a circle, looks like about 7 millimeters in diameter, so I'll enter that, and then I'll move and move him down over and down. And you can see this process can be a little bit tedious. This circle is probably a little bit small. If I wanted to really get a good optimization and minimize the mass, I would probably make this like an 8mm circle, increase it, and then I need to go around and do this same analysis or same development for the entire disk. In the middle here I'm simply going to come and put a rectangle, and I'll draw this rectangle about the center, so define from the center, and then draw this rectangle out, and I probably want to keep it in from the edges a little bit just for manufacturability, and so I'll go ahead and put my center there. And now I just again continue to do this. I'm going to put an ellipse in these holes, and to do an ellipse what you do is your first click is the center, then your next click is the angle of the major axis, and then your third click is the width of that ellipse. And now I've generated an ellipse, and what I'm probably going to do is simply take this ellipse here and copy and move it around the outside, and that's what I'm also going to do with the circle. So while I do that, I'll go ahead and turn off the video so that it's reasonably short. So now that I have completed building the geometry and putting holes where they need to be, I'm going to go ahead and extrude this or pull this geometry so that I can now create my solid and then apply my boundary conditions and my loads and look at the results. So I will rotate this a little bit, click pull, select this face, and you can see that I have the body there, but that's the body that I'm not that's the original body that I'm using. I want to make sure that I pull the face that I'm going to use. So I will come over here and click on facets and look at the facets. So once you have the geometry built, you're ready to pull it and apply boundary conditions and loads, and then look at the new results to validate the geometry. But before doing this, I just want to point out that since we deleted all of the lines, we had to generate a new outside line as well as generate these lines or circles for the holes. So now that we have them, we can go ahead and pull this into a new geometry. To do that, I'm going to get rid of everything that I'm looking at except the lines. So if I come over here and unclick that system, now all I'm looking at are the lines of what I want to extrude or pull. So I can come and click on pull, come down and highlight this body and pull it, and this was 3 millimeters, so I'll go ahead and type in 3 millimeters. Now I have the geometry that I want to make sure will carry the loads that I initially had. So to come up here, I'm going to make sure I have this solid active. These surfaces, I will right click and click on suppress for physics, and these should already be ready to be suppressed for physics, and this one's deactivated, so I'll go ahead and just leave it. So now I'll also get rid of looking at those surfaces, and I'm ready to go ahead and apply my boundary conditions. So I'll rotate this so I can get to those surfaces a little bit better. My geometry's good. I'm ready to minimize this and go into ANSYS mechanical. So I'll minimize the window, double click on model. Yes, I will read the upstream data. So I click on yes, and mechanical is starting. And now that mechanical has started, I'm ready to come and see how my geometry imported. So I have one solid, it looks good. My coordinate systems, I'm ready to mesh this. So now I'm ready to open ANSYS Mechanical. I will double click on Model. It says Starting Mechanical. Once Mechanical has started and opened, you can see that we have our geometry. If we come to the geometry, we should have one solid, and we have one solid there. We can look at it face on. So the geometry looks good. Now I have a question mark here by my mesh. So if I right click and try to generate mesh, it's not going to work. And what I need to do is I need to open up the mesh, and this refinement tool here will now not work for this new geometry. So I need to right click and delete that refinement tool, or that refinement, and now when I right click on mesh, because I have this lightning bolt, I will go ahead and get a mesh. So generate mesh. This is the default mesh that has come up. It looks pretty good. I'm going to just go ahead and use this mesh. So I will come down, and you can see my boundary conditions have now been replaced with question marks, and that's because they don't know what geometry to use. So I'll simply click on cylindrical support, and the radial, axial, and tangential settings are still as they were previously. And I'll just go ahead and click on these bolt holes and apply these to this new geometry. Now on my moment, I can click my moment. All I need to do is click the surface and click apply, and again the conditions that I previously had set are already there. I'm still going to look at equivalent stress, total deformation, so I'm ready to right click and solve. This solution, or this solve, does not take near as long as it did for the optimization. So I can go ahead and look at my equivalent stress. My scale for my deflections is a little bigger than I'd like, so I'm going to go ahead and just click on true scale. And now I can see the stresses in my member. All of these stresses look just fine. It seems like I could probably do another optimization and get rid of a little more material in this region. I knew that I didn't make my inside box as big as I could have, and so I have a little extra material in there. I have one high stress point over here. I can look at that, and The reason I have that is because this is a little bit too thin of a wall compared to the other ones. But the way I built my geometry, I just did it relatively carelessly and did a pretty rough model. So I would need to probably go in and give a little more material there, and this stress here would reduce quite a bit. So that's how you can do a topology optimization in ANSYS Workbench. I hope you enjoyed the video.